Okay, today I am going to describe a integrated rate law expression for first order kinetics. Okay, so I'll have to go through this. Integrated rate law expression for first order reactions. Right. So integrated rate law expression for first order reactions. Okay. So first of all, what is a first order reaction? So remember the reaction in which rate depends on only one concentration term. Rate depends on only one concentration term. Okay. See, the reaction in which a rate depends on only one concentration term is generally known as a first order reaction. And I said the reaction in which a rate depends only on one concentration term is generally called as a first order reaction. And one more thing, whose power must be equal to 1. One concentration term and whose power also equal to 1. Then only it is called as a first order reaction. Okay, let me go through the derivation part. Okay, assume an equation like this, a chemical reaction like this. A gives rise to products. हमेशा ये लेते हैं हम लोग. A gives rise to products. Okay. Now at T is equal to 0, that means at initial state of the reaction, let small a moles per liter of reactant is taken. Small a moles per liter. Where product is 0. Initially there is no product, only reactant are present, that 2 a moles per liter. Now at T is equal to T, let the product is x moles per liter. At T equal to T, let the product is x moles per liter. Therefore reactant left will be A minus x. After a T time, reactant left is A minus x, its product formed is x moles per liter. Now if you go through the rate expression, so rate of reaction is equal to dx by dt is equal to k into A minus x. Okay. So rate is equal to dx by dt is equal to k into A minus x. Okay. So we have to integrate this equation now. So writing from the top. So I'll have you go through this. Okay. Now you can write that expression as dx by A minus x is equal to k into dt. Now integral dx by A minus x is equal to k into integral dt. Right? Integral dx by A minus x is equal to k into integral dt. So ये सॉल्व करने से कितना आएगा? Minus log to the base e of A minus x is equal to kt plus constant, integration constant. Okay. Now at t is equal to 0, then x will be equal to 0. At t equal to 0 मतलब initial state में there is no product, that's why x is taken as 0. Therefore the value of constant is equal to minus ln e. So substitute this constant there. So therefore the above equation is written as ln A minus x is equal to kt minus log to the base e of e. तो kt is equal to क्या मिलेगा आपको? ln a by A minus x. Then k is equal to 1 by t ln a by A minus x. Then k equal to 2.303 by t log to the base 10 of A by A minus x. So this is the integrated rate expression for first order kinetics. K equal to 2.303 by T log A by A minus X. Okay. So, note down all of you. Please note it down. Now, if you take a graph of log A minus X versus the time graph. Okay. So from this expression, if you consider log A minus X versus time, then the graph will be like this, and intercept is about y-intercept is about log A. Right. Y-intercept is considered to be log A, and the slope equal to minus k by 2.303. Slope equal to minus k by 2.303. Okay, so this is the expression for first order kinetics. So all of you note it down. And one more thing, you can write this expression in exponential format also. Okay. In exponential format, it can be written as A by A minus X is equal to exponential power minus kt. ऐसा भी ले सकते हैं. In exponential format, A by A minus X is equal to exponential power minus kt. Okay, so this is the equation for first order kinetic exponential format, and this one is integrated right now. Okay, alright. Now when we go through half-life period or half-time period. Okay, Rafi, listen please. Half-life period or half-time period. Half-life period or half-time period. It is taken as a T half. Okay. Now, consider the rate expression for first law or first order kinetics, right? So K equal to 2.303 by T log A by A minus X. If T is equal to T half, matlab half-life period, then X will be equal to A by 2, because half-life means it is the time required to complete or to convert one half of the initial concentration of reactant into product. The time required to convert one half of the initial concentration of reactant into product is considered to be half-life. So X equal to A by 2. Substitute these values here. Then K equal to 2.303 by T half into log A by A minus A by 2. Then T half is equal to 2.303 by K log A by A minus A by 2. That will be A by 2. Solve करने से log 2 मिल जाएगा. So T half is equal to 2.303 by K into log 2. So log 2 value is 0.3010. So therefore T half is equal to 2.303 into 0.3010 by K. Then T half equal to 0.693 by K. Right? So T half is equal to 0.693 by K. So clear? So this is about half-life period or half-time period. Okay. Now, see, if you consider the graph of T half versus initial concentration, it is like this. So parallel to concentration axis. What does it mean? So half-life period is independent of initial concentration. Okay, half-life period is independent of initial concentration. Then it is called first order reaction. So at last write that point please, Rafi. For first order reactions, half life is independent of initial concentration. Right? For first order kinetics, half life is independent of initial concentration. So that's it. Look, it's about half life period or half time period. Okay. Now, see, let me go through some examples. After that, some calculations based on first order kinetics. Right? Listen carefully. Now, let me go to examples for first order reactions. Okay. See, decomposition of hydrogen peroxide, decomposition of H2O2 follows first order kinetics. If you take the equation 2H2O2 gives rise to 2H2O plus O2, even though it can be expressed like this, rate is equal to K into concentration of H2O2 power 1. Right. It's the first order kinetics. It follows first order kinetics, that is decomposition of hydrogen peroxide. One more head, decomposition of NH4NO2, ammonium nitrite. Okay. Decomposition of NH4NO2, ammonium nitrite, also follows the same. Okay. NH4NO2, when it undergo decomposition, what it gives? N2 plus 2H2. So R is equal to K into concentration of NH4NO2. But this is also comes under first order reaction. Is it clear? NH4NO2 decomposition and N2O5 decomposition also. Dinitrogen pentoxide. Okay. So N2O5. If you take 2 moles also, correct? For balancing purpose, we are taking 2 moles of N2O5. That gives rise to 4NO2 plus O2. So R is equal to K into concentration of N2O5 power 1. So these are all examples for first order kinetics. Is it there? Still so many are there. Decomposition. Maximum decompositions comes under this category. SO2Cl2, sulfuryl chloride on decomposition gives SO2 plus Cl2. Here also R equal to K into concentration of SO2Cl2. Right. So these are all comes under what you call first order reactions. Apart from this, sir, is there any other examples? Apart from this, remember radioactive disintegration. Radioactive disintegration follows first order kinetics. Radioactive disintegration always follows first order kinetics. This is the first thing. Second, bacterial growth. Bacterial growth also follows first order kinetics. अब ये दोनों याद रखिएगा. Radioactive disintegration and as well as bacterial growth also follows first order kinetics. Okay. Radioactive disintegration and bacterial growth. So I want to explain this bacterial growth. Bacterial growth or bacterial multiplication. You can call it as bacterial replication, etc. So the growth of the bacteria, better to say the division of bacteria also follows this first order kinetics. Okay, the division of bacteria also follows first order kinetics. Okay. See, A bacteria gives us so many. See, we always write the equation like this. A gives rise to product. A is one bacteria which divides, division, several bacteria. So A is bacteria, products means several bacteria. Okay. Now, at T is equal to 0, let me consider this A moles is 0. After some time, इसका X, तो ये कितना होगा? A plus X में क्योंकि दिस इज नॉट केमिकल रिएक्शन, इट इज बैक्टीरियल ग्रोथ। सो थोड़ी देर के बाद इनिशियली ये मोल्स ऑफ बैक्टीरिया लिया, थोड़ी देर के बाद एक्स प्रोडक्ट्स आ गया, तो अभी कितना आएगा, ए प्लस एक्स आएगा, इनिशियल प्लस अभी डेवलप्ड बैक्टीरिया। सो यहाँ पे ए प्लस एक्स लेना पड़ेगा, दैट्स द मेन डिफरेंस। नॉर्मल केमिकल रिएक्शन में ये एक्स मोल्स लेंगे तो रिएक्टेंट लेफ्ट ए माइनस एक्स लेंगे, बट बैक्टीरियल ग्रोथ में अगर प्रोडक्ट इज x moles per liter, then reactant should be a plus x after theta. Okay. Then a rate can be written as rate is equal to dx by dt is equal to k into a plus x. Okay, then dx by dt is equal to k into a plus x. Now dx by a plus x is equal to k into dt. Now integral dx by a plus x is equal to k into integral dt. तो ये कितना है, माइनस ln a plus x, राइट। बिफोर क्या, माइनस ln a माइनस x, यहाँ पे माइनस ln a plus x is equal to kt plus constant. This is the integrated expression. Now, if t is equal to 0, then x is equal to 0. Therefore, constant will be equal to L log to the base e of a. So, minus ln a plus x plus kt log to the base e of a. Now, kt is equal to, what you are getting? ln a plus x by a. ln a plus x by a, and k is equal to 1 by t ln a plus x by a. Now k equal to 2.303 by t log a plus x by a. Now it can be written like this also, k equal to minus 2.303 by t, just make it as negative, log a by a plus x. So this is the rate expression, integrated rate expression for bacterial growth population or bacterial growth. So माइनस लिख रहा हूँ यहाँ पे, ठीक। अगर प्लस थे तो 2.303 by t log a plus x by a. Now it is written as minus 2.303 by t a by a plus x. So that's it. It is about integrated rate expression for bacterial growth or bacterial population increase. Okay, so have understand it? Okay, right. Next. Okay. Now, all of you go through one more important point. Just to put a note. अगर two different time periods दिया गया तो, ठीक? Okay, if you see the expression, you can understand. So don't worry. What I am taking here is A gives rise to products as usual. एक first order reaction लिया हूँ. From it follows first order kinetics. A gives rise to products. Now, at t is equal to 0, at t equal to 0, initial state, let me take A 0. Now, at t equal to t1, babu, at t is equal to t1, then let me make this one as x1, then ये वाला a minus x1 मिलेगा. Now, at t is equal to t2, then it will be x2, and this one will be a minus x2. Okay. Understand? So this is about two different time periods. Initial, उसके बाद T1, उसके बाद T2 लिया. Okay. Then what is T1? T1 equal to क्या ले सकता है? 2.303 by k log a by a minus x1. अब T1 is equal to 2.303 by k log a by a minus x1. T2 क्या होगा? T2 is equal to 2.303 by k, क्योंकि rate constant तो same है ना दोनों में, rate constant is always same, and initial concentration is A, so A minus x2. तो यहाँ तक समझ गया ना। T2 minus T1, if you go through T2 minus T1, okay, T2 minus T1, so इन दोनों का इक्वेशन सॉल्व कीजिएगा, कितना मिलेगा आपको 2.303 by k log, right? So T2 minus T1, तो कितना मिलेगा a minus x1 by a minus x2, or it can be written as k equal to 2.303 by T2 minus T1 log a minus x1 by a minus x2. Right. So please note it down. When you take two different concentrations of product at two different intervals for a first order kinetics, you can derive an equation like this. Please. Now I am going to explain that radioactive disintegration, rate of radioactive decay. Okay, now if you go through this, a rate of radioactive decay. Okay, see, radioactive decay or radioactive disintegration, it always follows first order kinetics. Okay, now assume a radioactive disintegration. But again, I am taking the same. I am taking a radioactive disintegration like this. A gives rise to product. Okay. Now at T is equal to 0, let me take initial concentration as N0 and it is 0. Now at T equal to T, after certain time period, I am taking this one as N. Okay. The concentration left is N. And ये कितना होगा? Product N0 minus N. Okay. After some time period, the reactant left is taken as N. Then the product concentration will be N0 minus N. Clear? Now, therefore, rate of decay or rate of disintegration will be equal to kya? Rate of decay or rate of disintegration is equal to amount disintegrated by time. Amount undergo decay by time. Okay, so what you are getting N0 minus N by T. Amount undergo decay divided by time. Okay, right. Now, so as per first order kinetics, minus D concentration of N by dt is equal to K into concentration at the instant of time is N. Right. So this equation में K means a rate constant. Now I am taking it as lambda. But lambda is called as decay constant or activity constant. Lambda is known as, see, in normal first order reactions we are using K, but in radioactive disintegration we are using, instead of K we are using lambda. Lambda is called decay constant or activity constant. Okay. Now minus dn by n is equal to lambda into dt. Minus dn by n is equal to lambda into dt. Okay. So इसका इंटीग्रेट करेंगे. Now I want to write like this. Okay. So I am writing this one as dn by n is equal to minus lambda integral dt. Okay. dn by n minus lambda integral dt. तो ये कितना आएगा? ln n मतलब log to the base of n is equal to minus lambda t plus constant. Now at t is equal to 0, then n equal to 0 ना? At t equal to 0, n equal to 0. नहीं है तो एक काम कीजिएगा, कुछ t 0 मतलब इनिशियल कॉन्सेंट्रेशन ही होता है ना, सो n जगह n नॉट लिख सकता है ना आप लोग. मैं पहले जो जीरो लिखा हूँ वो सही नहीं है. If T is equal to 0, initial step, the concentration of A will be the initial, that is N naught. So therefore, constant value कितना आएगा? Constant is equal to ln N naught. Okay. So log to the base C of N is equal to minus lambda T plus log to the base C of N naught. Okay. तो lambda T is equal to क्या मिलेगा? ln N naught by N. Okay. So lambda is equal to 1 by T ln N naught by N. ln means log to the base. Then lambda is equal to 2.303 by T log N naught by N. Okay. So this is the expression for radioactive decay or radioactive disintegration. Okay. और एक्सपोनेंशियल फॉर्मेट में क्या लिखते हैं? n is equal to n naught exponential power minus lambda t और n by n naught मतलब वहां पे a by a minus x लिखा है ना वैसा यहाँ पे n by n naught is equal to exponential power minus lambda t. So please note it down. Okay. So that's it. It's about integrated rate expression for radioactive decay or radioactive disintegration. So as usual, you can find a half-life or something, etc., etc. Okay. So if you go to half-life, right? अभी देखो k वैल्यू कितना है आपको? k वैल्यू मतलब सॉरी लैम्डा वैल्यू कितना है? 2.303 by t log n naught by n. At t is equal to t half, n should be equal to n naught by 2. Therefore, lambda equal to 2.303 by t half log 2 आएगा. So n naught divided by n naught by 2, that will be log. So log 2 value 0.3010. Therefore, lambda equal to 2.303 into 0.3010 by t half. So t half is equal to 0.693 by lambda. So like that you can get the half-time period or half-life period of a radioactive disintegration or radioactive substance. Okay. Understand? So here also say t half is independent of initial amount of radioactive substance. Half-life is independent of initial concentration. Next, one more important point. All of you please listen and remember. See, it is not possible to calculate total life period of a radioactive substance. नहीं है तो of a first order reaction. Oh, it's a very important point. It is not possible to calculate total life period of a first order reaction. सर ऐसा क्यों सर? सुनिए बाबू, 1 ग्राम हाफ ग्राम होने के लिए एक हाफ लाइफ लगेगा, फिर 1/2 1/4 होने के लिए अनदर हाफ लाइफ, 1/4 1/8 होने के लिए अनदर हाफ लाइफ, ऐसा कंटिन्यू होते जाएगा. So you are unable to find exact half life period or exact half time period of a first order reaction. Sorry. You can find exact half time, but you cannot find exact time to complete a first order reaction. So it's impossible because it becomes infinite. It is impossible to find exact time period of a first order reaction. Okay. So therefore, remember, instead of complete or total life period. Instead of complete or total life period, we can able to calculate average life period of a first order reaction. अब मेरा बात समझ गया? So 100% कंप्लीट होने के लिए फर्स्ट ऑर्डर रिएक्शन के लिए कितना टाइम लग रहा है वो हम फाइंड आउट नहीं कर पाएंगे, वो इनफिनाइट आ रहा है. इसीलिए टोटल लाइफ टाइम की जगह आप एवरेज टाइम आप फाइंड आउट कर सकता है, एवरेज टाइम। ओके, सो एवरेज टाइम कैन बी कैलकुलेटेड। ओके, सो TAV, that means average life. Okay, so TAV is taken as average life. तो एवरेज लाइफ कैसे कैलकुलेट कर सकता है? व्हाट इज दिस एवरेज लाइफ? समवन, अब इट इज द रेसिप्रोकल ऑफ एक्टिविटी कांस्टेंट। रेसिप्रोकल ऑफ एक्टिविटी कांस्टेंट मतलब 1 by लैम्डा नहीं है तो 1 by k ले सकता है। T average is equal to 1 by lambda. Okay, now आपको पता है ना T half equal to 0.693 by lambda. Okay, therefore what you can write here? 1 by lambda जगह क्या लिख सकता है? T half is equal to 0.693 into T average. Okay, so therefore T average is equal to 1.44 into T half. Right? So please remember this expression. T average मतलब average life period is equal to 1.44 into T half. 1.44 into T half. Is that clear? Okay. So this is about average life period or average time period. Okay. So आज के लिए यहाँ तक हम छोड़ रहे हैं। So इसके ऊपर कुछ calculations and some more important terms I'll complete by tomorrow's class. Okay. Until then, bye bye. I love you. Thank you so much for your cooperation. So kindly please extend your cooperation. Please like, share, and subscribe this channel and give some valuable comments also. And must and should please share it, like it, and subscribe it. Thank you.